Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to look at how to solve question 10 in this question paper. Question 10 is from Unit 6, Space Physics. In this video, we're going to do an immediate comparison of our answer against the mark scheme to ensure that we have written all the correct keywords and concepts to maximize the marks that we can get, as well as to check that our calculations are correct. Let's start. The Milky Way is one of many billions of galaxies. Each galaxy contains many billions of stable stars. A. Stable stars transfer energy into space by emitting electromagnetic radiation from their surfaces. Describe what happens in the core of a stable star to release energy that is eventually transferred into space. This is a 3-mark question where you need to describe what happens in the core of the stable star. So what happens in a star is that there is nuclear fusion reactions happening that causes the hydrogen to fuse into helium. This nuclear fusion is what releases energy from the core of the stable star. So that's the answer that we're going to write for this answer. This is merely a description question. You don't have to explain. So you just need to state and describe what's happening inside the star. So what we can say is that the hydrogen nuclei undergo nuclear fusion reactions to form helium nuclei. So when you want to write down what happens, you do have to explain in full. So that's why we need to mention what it starts off with, what it undergoes, and what it ends up becoming. Let's have a quick check against the answer in the mark scheme. So you can see for this question, hydrogen nuclei fuse to become helium nuclei. And this alone already can give us 3 marks. So the key thing is that you must mention that it starts off with the hydrogen, undergoes nuclear fusion reactions to form helium. And these are the 3 key things they are looking for to award the 3 marks. Now, if you didn't write all 3 out, you can still get some marks. So if you look at the mark scheme, here's how to get marks if you didn't write all 3 concepts. So as long as you mention nuclear reaction or nuclear fusion, you can get 1 mark. And if you mention that hydrogen fuses into helium, you also get 1 mark. As you can see, what's missing in these 2 options is the term nuclei. So do mention that the hydrogen nuclei will fuse to form helium nuclei. Move on. B. On the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving away from the Earth. Number 1. Describe how the observed light is different from when it was emitted. So again, this is a description question. We just need to describe how this light is observed to be different from when it's actually emitted from that galaxy. The question has already told us that the galaxy is moving away from us. So why is it different? Because when it's moving away, if you can remember, the light will be red-shifted. However, when writing the answer out, don't just say red-shifted, because if you just write, oh, the light is red-shifted, that doesn't really describe how it is different. So to our eyes, the wavelength appears to be longer than it actually is, because that's what redshifting means. Redshifting means that the wavelength of the light has shifted towards the red end of the spectrum, where the wavelength is longer. So the perceived light appears to be longer in wavelength compared to when it was first emitted. So that's how we should describe the answer. So the wavelength of the observed light appears to be longer than when it was emitted. Let's check our answer against the mark scheme. So as you can see here, the observed wavelength is longer, and that's what we wrote. Now, if you didn't write this, an option is to write that the wavelength is shifted towards the red end of the spectrum, as I had mentioned earlier as well. So this is also an accepted answer. Writing either one of these would give us the 2 full marks. Now, if you have just written red shifted, as you can see, you'll only get 1 mark. You're not going to get the full 2 marks. So remember, the reason is because you need to describe what we see The term redshift is an explanation of a physics concept, not a description of what is being observed. So that's why just using the term redshift is not enough to get you the full 2 marks. You need to describe how the light appears to be different. So that's what the question is asking for, and that's how you get your 2 marks. Let's look at number 2. State the quantity that astronomers use to determine the speed at which the galaxy is moving away. Now, we can't actually measure the speed which the galaxy is moving away because it's so far away. So instead, the astronomers will find another measurable quantity that we can use to represent this speed instead. So if you can recall, instead of measuring the speed, we can measure the change in wavelength, not just the wavelength. Because in this case, the galaxy is moving, there's a change in distance. So we can measure the change in wavelength. We can't just write wavelength on its own because wavelength kind of indicates that it is static. In this case, the galaxy is not static, it's moving. So when there's movement, there's a change in the wavelength. That's why, change in wavelength. So I'm stressing on this so much because if you check the mark scheme, you can see the term change is underlined. You must have the term change to get the full mark. Not just change, by the way, change in wavelength, yes, but the word change must be present in the entire answer. So that's how we get the mark for this question. C. The Hubble constant is equal to 2.2 times 10 to the power of negative 18 per second. Number 1. Calculate the distance from the Earth of a galaxy that is moving away at a speed of 1.3 times 10 to the power of 7 meters per second. So to solve this, you need to use the formula involving the Hubble constant, the distance of d, as well as the speed. And that formula is h naught equals to v over d. And we're looking for d. So all we need to do is substitute the values in. So that's 2.2 times 10 to the power of negative 18. V is 1.3 times 10 to the power of 7, and d is unknown. So to find d, we're going to swap this out. So d would be 1.3 times 10 power of 7 divided by 2.2 times 10 power of negative 18. So this should give us about 5.91 times 10 to the power of 24 meters. So when writing the answer for calculations, you can write 2 or 3 significant figures. The preferred one is 2 significant figures. So I'm just going to write 2 significant figures in our answer as so, together with the unit. So let's have a quick check of our answer against the mark scheme. And yes, there we go. Correct value with the correct unit, and that gives us the full 2 marks. Now remember, if you didn't write the correct value with the unit, then the examiner will have to look for the marks in your working. So either the correct formula or correct substitution. That would give you at least 1 mark. Now let's look at number 2. Calculate an estimate for the age of the universe. Give your answer in years. So I know some of you have probably memorized this value. You don't actually have to because you're given the Hubble constant. You can actually calculate the age of the universe by taking the inverse of the Hubble constant. That means 1 divided by 2.2 times 10 to the power of negative 18. So this would give us times 10 to the power of 17. Because it's per second, this gives us the value in seconds. However, the question wants us to write our answer in years. So we need to convert seconds to years. So you'll be able to get it by dividing this value with 60 seconds for minutes, 60 minutes for hours, 1 hour has 24 days, and 1 year has 365 days. So when we calculate this out, this would give us about 1.44 times 10 to the power of 10 years. So in IGCSE, we prefer to write up to 2 significant figures, so we can just write 1.4 times 10 to the power of 10 years. So checking this against the mark scheme, you can see, yep, we got this correct. Okay, so if you hadn't gotten this correct answer, then the examiner would have to look for marks in your working, which means that you have to show the inverse of the Hubble constant. And that's how you solve question 10. So if you'd like to find out how to solve the other questions in this question paper, please refer to the playlist in the video description. Happy studying!